It's
Okay.
got a more message here. What's going on? So a couple of things that I've been working on. One is so this is the inside is a nano and also a magnetic rotation sensor. And so I've been working on a housing that basically, if I get out and it starts to sprinkle, I don't have to stop immediately. And I've got a top for it, but it's obviously not showing that. So that's pretty much, I'm probably 80 or 90% done with that. And again, this rotation is 1 revolution is 16,000. I don't know what the right word is. I always just say ticks, 16,000 positions. So, you know, is that like a 14-bit? Is that 14-bit, 16,000, 14-bit encoder? The other thing, as I posted in Slack, I started the process to mount the steering motor for my second lawn tractor. And that's, having a motor mount is really helpful. That I posted pictures of. And I'm just trying to share something here. And then
turns out only one picture did come through. It's kind of just a shot looking down with your bracket bolted on.
Let me see if I can post the other photo. Maybe it only takes the second one when you share. Random. Okay, hopefully that'll be on its way. I'm sure if you thought about it very long, you would realize hooking up that motor also involves cutting the steering rod that comes with the tractor, and you only get one shot at that. So, you know, that adage about measure twice and cut once. I have some instructions, and I've 3D printed a couple of things to help me do that. So I've been writing my instructions, and basically it's a process of what I happen to use is this U-joint that sits between the motor and the steering rod. And so I've got to cut the motor so that or the steering rod so that it, you know, comes up to there. And my preference is that sits straight as opposed to, you know, although that's what a U-joint is meant to do, is to deal with that angle. But my preference is to try to get that as straight as possible. So I spent a lot of time trying to get the steering rod to match exactly up to that point, which is, you know, hollow. So you can stick your finger in, but I don't want it to stick way up there. I want it to be right back there, you know. So my process for doing that is to cut it off about where I think it needs to be, which according to the first tractor is 105 millimeters. And then I take a holder, if you will, and put it on the shaft and bring it up to here, and then screw that down, and then take another set of holders so that I can hold the U-joint on the drill press flat. So one would be here and one's here. And so I can drill, hopefully reasonably straight hole through a cylindrical object. And that's my slow and torturous process for getting a hole in a U-joint, hopefully straight. So anyway, that's my today task. That's where I'm at.
Okay, I did finally find my pictures, and let's see, can I share my screen? Let me try it. Screen 2. And then let's open this. Okay, so there's a, I'll just randomly go through these because they're not in the right order, but anyway. So there's kind of a side view, and it's got the motor's hanging down, and sticking up on the motor is the output shaft. There's a sprocket on that. And then here's the steering shaft in the front. So there's a bearing bolted onto that. And I just put a steel collar down here as a reference point. And the thing was, let's see, can I back up far enough? Let me go to this directory. And let me say,
those are awesome photos.
they're just random pictures. So, okay, can you see that new one?
Yes.
You should be able to see this one. This is, here it is with the plastic housing, basically the dashboard on, and then the steering wheel. I might be able to get that on and put the steering wheel on, but then I don't have room for the sprocket. So where I had this yellow tape, I was going to cut down. Let's see, do I have that next one? See, I had that yellow tape. I thought, well, I'll cut down there so I can just drop the whole thing down into there. But I decided that if I do that, I'm having problems with stuff here. Okay, so if I did that, it turns out the bracket was going to hit this backup push button and the ignition switch. So I was going to cut it out and just drop it in there, but then I decided, well, if I take it off, and I can actually cut the notch up from the bottom, so I'll actually put the thing on and bolt it in place, because I can't assemble it. It will not fit. I can't get it to fit through this hole that I cut, and even if I cut these holes, it's going to make a mess. So I finally just took the end off, and let's see how to get back to. There we go. Here's the new set of pictures. So that's the first one. This is just kind of looking at it from the front, where this is the bottom. There's another plastic. The bottom piece is plastic, and it comes around here. So the plastic fit over the top of that. Let me just see if I can get some better angles here. So right here, this is towards the bottom where that plastic housing was. And if I back up even further, you can see. So essentially, the plastic housing came all the way up to the steering wheel here, and then came down at the same angle as the shaft. So basically, I just took that whole plastic piece off. I've got this slid down pretty much as far down as it'll go, and that's all depending on. Right now, the shaft on the bottom is sticking out, and at this point, I had this. This is actually laying on the bottom of the thing here. And if I raise it up a little bit, I put a set of Allen wrenches under there, a little plastic thing to raise it up. But my problems are at this point, number one, I got to keep this short enough. It turns out when I raise my seat over here, the seat tilts forward so you can get into the battery and whatever else is under there. And if this is up too high, then the seat runs into that. So that's one problem. The next problem is this handle down here at the bottom is what lifts the that sets the motor deck height. So that has to go up and down. So I can't hit that. And then the other issue is somehow I gotta brace the back of this down to the frame. So I'll either come back to a hole here or a hole down here, or maybe just run it down, say in front of this thing somewhere. And then once I'm done, I can cut the shaft off if I need to, if it's going to be in the way. So basically that's, I had one other, this kind of gives you an idea of, see, the steering wheel is still up here, and I should be able to put the steering wheel back on and put the plastic cover on, and it'll come up here somewhere. So it'll just be from about this point out to here, sticking out of the plastic, and then all this stuff will be bolted inside. So that's kind of where I'm at with that. And I've just got this long threaded rod stuck through. I thought it was 3/8, but it turns out it's 5/16 rod. So it's either 5/16 or 8mm, which are about the same size. And of course, I got to buy to a hardware store. I had to get 5/16 to put through there. And in the final picture, I think I'd already cut that off. No, I hadn't. One of the pictures I have, I think I cut that off. Well, I guess not. Maybe it's still on the camera and I just haven't unloaded it yet. So anyway, these are just, again, there's the string shaft going up and down at a kind of a strange angle. It's got this bearing bolted on there. So then the side rails, I slotted the, let's see pictures of that. So even though I got lots of pictures and you think they're good pictures, right here you can kind of see I slotted the material there to bolt the bearing on. So theoretically I can slide the motor back and forth to tighten up the chain. And then otherwise, I think I'm gonna have to put it on and bolt everything into place. When I'm all done, I'll go ahead and drill. I'll just drill a hole through this shaft and put a bolt through there. But I want to get everything lined up first, so I know where everything's got to go, and then hopefully that'll work. Because once I put it together, I don't think I'm going to take it apart again. So hopefully I can get it on and get the cover put on, and then it'll work. And then if not, then I'm going to tear it apart again. So that's kind of where I'm at with that.
Can you go back to a picture where you've got the shaft, the motor shaft all the way down, hitting your flat piece of metal with a warning sign? Yeah, that one will do. So if I'm just thinking out loud, and not that you would want to, but if you took a piece of metal and came straight down from your angle iron there, just a little bit to the right of your mounting hole, and you went all the way down to if you just drew a straight line down from there to your deck,
Yeah.
you'd be able to lop off the rest of that angle iron. If that was your support point, as opposed to going all the way back to your seat bracket.
Yeah. I was going to cut this off anyway back here, but I don't know yet where I need to do that. So I need to weld some kind of a brace across to tie the two together, because right now the only thing holding it is the two bolts on the front. So I should weld a brace across the front and then come back here and weld a brace, then cut off whatever extra is there. And one thing I didn't mention was right now the motor is hung on this shaft or this big screw right here. It can pivot, so it can actually turn like this. So I need to come down here and grab one of these on the face of this down here. I need to take one of those holes, and either if I run a bracket down the back here, I need to run something over and weld onto that, or as you say, if I run something straight down here, I can just come across and pick up the hole to grab that. So yeah, that's still something else yet to figure out.
Yeah, and so your steering shaft, so starting from the bottom and working up, that silver piece, is that new or was that there?
Which silver piece?
So if I'm looking at your picture, I see black plastic shroud.
Yeah.
I see your, mild steel steering shaft, and then the first thing I see is a shiny piece of aluminum before I get to the blue
Well,
collar.
it's actually a shiny piece of steel that's on there. And that just, it's just one of those collars that it's got a set screw, so you slide on the shaft and tighten it down. I'm just going to use that to keep the thing from sliding down too far. That's what that's for.
Is
And
that
right now,
permanent?
is it what?
Are you intending that to be permanent?
Yes. I'll just find somewhere to put it and lock it down. That'll just set my reference point. So I just slide the bearing down till it hits that. There is actually another set screw in the bearing. Let's see, do I have a closer picture of that? If I go back to my older pictures, since these aren't all in the same spot, it can be harder to find this. Let's see, can I do here? This set of pictures. Okay, let me see what I got here.
And again, a lot of this is because you want to retain the ability to steer this thing with the steering wheel, right?
Yes. Right here, you can kind of see over here on the. I probably can zoom in on this. Oh no, I'm on Windows. How do
It's
I do
really,
this?
it's fine.
Here we go. I have no idea where I'm at. Oh man.
I think if you do control
Right there. See,
wheel.
I don't know. Anyway, here's the bearing, and say on the bottom of the bearing, there's a set screw here and a set screw over there, and I don't know because the bearing doesn't really care. It doesn't have to be locked to the shaft or anything. It's just a matter of controlling the height of it, and that's why if I put that steel collar right here and bolt it down tight, then this thing can just lay down against it, and that's what that's for, the other piece. And I thought I had some better pictures, but I guess I don't. So let me go back to this thing. And so from this angle, see coming up, here's the shaft. This is the actual bearing for the steering shaft right here, the existing bearing. And it had a bearing there, and then the steering wheel is way up here. It's like this high, like 6 inches or something above there. And there was originally the plastic piece that I cut off, which let's see, how could I easily do this? So here's the piece that I cut off that was on top. And this, you can see on the shaft where there's a smooth spot. So the shaft actually rubs against that. So that was the only thing holding the top of it. So you had, about this much, you had about this much shaft sticking up where there's a bearing at the bottom. The steering wheel's up here. And so you got a lot, you could get a lot of force back and forth on that. But being a 3/4 inch shaft, it's quite rigid. And as I say, this piece of plastic kept it from going too far. So anyway, now that I put my thing with the share screen, this one. Okay, so the fact that the existing bearing for the lawn tractor, and this is just a big plastic chunk. I thought it was made out of steel, but it's not. It's made out of plastic. So down here, it's just got a hole going through, and that's the lower bearing. And then there was no other bearings until you got up the steering wheel here. So I just wanted to also run this down fairly close to that if I can. So if there's any extra forces applied, it's not going to try to bend anything or whatever.
That looks like steel rod to the left there. What is that?
This is the handle to run the blade clutch. So you just move that back and forth, and that was a problem too because it didn't want to come out of the plastic housing. So I ended up cutting it. Do I still have that picture? See on this set of pictures. So right here is where that comes up through. And again, there's just a hole through the plastic. Then they have this like a big plastic thing stuck on there. It's like when you put a power cord in, so you wrap this around the power cord and take your pliers and shove through the hole, like a big grommet, big plastic grommet or something. So that was stuck down through there. So that was the bearing surface when you turn this handle, because this, see up like that, I think that's the engaged position, or if you pull the lever that sticks out 90 degrees to the right, that's the unengaged position. But in order to get this cover off, I had to get that out somehow. So I ended up just taking something and cutting out this piece here. So So that freed it up, and then I can pull that handle through the big hole here to get it out. So it's just more screwing around to make this stuff work, and that isn't really what I was expecting. So
What do you recall what chain dimensions you used, pitch and whatnot?
it's number 35 chain, which is what you use on go-karts and mini bikes. And I have those sprockets laying around. You can buy that chain either on Amazon or eBay, or go to the local farm store and get that. So I ordered a new 10-foot roll of that because I couldn't find my roll of chain. So what I have to do now, since I slotted this, I have to figure out, get it approximately where I want it, then put a piece of chain around here and figure out the right length, and I'll cut it off. And then once that's on there, I can pull the thing back against the slotted holes till I tighten it up. Because I need to weld right here. I need to weld this bracket onto these two together. I just got C-clamps right now holding it together. So I have to weld those together. And then I'll have to weld a brace across the front, a brace across the back. And so that's kind of what's holding me up right now. I just got to get the chain on there and figure out, because on the chain, you go like every 1/4 inch or something is how, maybe it's 1/4 inch or 1/2 inch. Once you cut it, then that's what you get. So that's why I have the slotted holes in there. So that's where I'm at with that, is trying to figure out, I got to figure out how long the chain's to be, then I can figure out how back far this goes. And then I can pull out the welder and start welding stuff together and see where it goes from there. See how much of a mess I can make.
I have no fabricating skills whatsoever. The guys who have made some brackets for me before, they were liberal users of slots. So you might think about slotting, if you took where your bolt runs through and you've got that angle iron there, if you had a slot in that angle iron.
Oh, there is, because right here there's a 3-inch slot right there, and there's a 3-inch slot right here that you can't see. So yeah, I've got a slot in there. I can move that back and forth to adjust that. And so far, that's the only adjustment I've got.
That's cool.
And I normally don't even think about slots because that's just too hard to do. Well, it turns out I've been watching people on YouTube, and they just make them all the time. You take a drill and you drill a hole at both ends of the slot. You take out your angle grinder and just cut out the long part in between until it looks like a slot, and you're all done. So that amazed me that you could do that. And I tried it and it seemed to work. Here, this might be a better picture of my slots. So right here, you can see here's a slot that starts here.
You have tons of space. Yeah, you don't have to be too fancy on your chain length. You got all kinds of adjustment.
I do. It's just that I want to keep the motor as close to this plastic as I can.
Yeah.
And but I have to keep it far enough forward that I don't bang into stuff at the back. So it's just a matter of, as I say, if I get like a 1/4 or 1/2 inch play, I just have to go ahead and set this first, and then put the chain on and say, okay, which way do you want to go from there? So it's just a matter of it. The slots probably didn't have to be that long, but that's what I've got. So that's what I'm going to go with now.
And then your sprocket on the motor, I'm not remembering what was on. I mean, there's a spline on one end. There's a spline on that end too. How did you find something to fit that darn thing?
Well, it turns out if you go to the hardware store and buy their, I think they call it 3/4 inch aluminum tubing, the inside diameter just exactly fits on top of those splines, and the outside diameter is 3/4 inch. So I put the sprocket on that. So it, I don't know if I've got any pictures here that.
And so what we're looking at there.
So right here, this is the main drive shaft coming out, the one that you've got hooked to your U-joint.
Mm-hmm.
And this right here, there's a piece of aluminum tubing that runs like that. And the tubing just coincidentally happened to be the right side inside diameter. I actually put it on. And if I wiggle it hard enough, I can get it to go on. I think I ended up just taking a 2x4 and pounding it on. And then the outside diameter, that is 3/4 inch, and that's the size of my sprocket. So I ended up pounding the sprocket on too. So it all went together coincidentally, just dumb luck. It all went together fairly well.
And how did you get the center hole in your shaft? Did you take it out? Did you take it out of the motor? Did you take the shaft out of the motor?
You're talking about the hole that goes right down the center of the
No,
thing?
the
This
in
one?
this, yes, the vertical one.
This one I had it, with it bolted down to this piece of wood, I just put it on my drill press and drilled it, and it turns out it's not straight. So the back side here is closer to the back, and the one down here is closer to the front. So originally I had a hex head on there, and that would hit my chain as it went by. So I found this round head screw to put on there. So it's not good to do it this way, because now this is the only thing that will ever go on there. If I try to put a different sprocket on, well, the hole in the shaft is already drilled, so that's permanent. So then I have to figure out, I have to somehow get the drill a new hole in the sprocket on this side and get it to come out this side at the right spot. So that wasn't really the best way to do it. I see that your thing with your drill guides are probably a very good idea to do that, but this is the way I did it at the time,
Hey,
and I think it'll work. As long as I never take it off, I should be okay.
the only thing you've committed to is your motor, and you've got a drill hole that's slightly off center. I've hacked my whole lawnmower, so I'm committed. This is sort of the way I look at it. You could get back
Yep.
to fully functional. That's
So
awesome.
now I'm just waiting for some warmer weather. So, and it might be warm enough today to do something, but I just got to go out and I got to stand there, look at it for a while, and move stuff around, and say, okay, that's it. I'm gonna weld everything down and be done with it. So, we'll see how it turns out.
I think that's fantastic. I struggled so long getting the darn mechanical steering organized, and that's awesome. I think what you've got going on there.
So the other thing that I've been playing with, this is my that is a Teensy with a BNO055 IMU module on it, and that's just some random thing that I bought on eBay. And I got two of them, and one of them doesn't work. It seems to be shorted out, and this one does work. And I found some code on the internet to load on it, and it does something. And then the other one is this is a Teensy with that Teensy, or it's a Teensy with the Tindy IMU module on it. And I finally got that to work after a lot of screwing around. He says that it's using the Teensy I2C underbar T3 I2C driver or something like that. And it turns out the code I'm using, no, it doesn't use that. It was apparently for an ESP32 or something. So I spent hours trying to get that to work, and I still can't get it to work right. So I have to, when I run his code, I have to hook up the I2C pins on a couple of set of pins, and then to load the calibration software from a different guy, I have to move those wires to do that, just because I haven't figured out the Teensy yet to get that to work. I haven't figured out how to modify his code to use the Teensy driver that I'm supposed to be using.
Are both of those boards you just showed BNO055s?
No, this one is.
And who sold you the board?
It's somebody on eBay.
And
And
so
now again, I'm going to make the statement, just because I'm showing it doesn't mean you should run out and buy this stuff.
no, I'm not.
I'm saying I had these and I hooked them up, and they seem to be working a little bit. I have no idea if they're ever going to work right or not.
I think I probably own 6 IMUs.
And if you are foolish enough to buy one, I would say, and if you got enough money, you've got a job, I'd say go to Adafruit and buy theirs, because number one, they're going to test it first. You're not going to get a board that's shorted out like the one I had, or it could be that I did that. I was trying to solder some jumpers on it or something. I might have shorted it out. And theirs also has the level translator, so you can randomly switch it between a 3.3 volt processor and a 5 volt processor. And I had to have, this one has no external level translator, it's just the chip and a crystal and a voltage regulator on the board. So I picked a 3.3 volt processor, and that's why I went with the Teensy. And it turns out the guy that is Chris Weiner that does all the IMU stuff, he uses Teensys for his stuff, so that it worked out well to do it this way.
So I think the last IMU that I bought was actually the newest one that Adafruit has. It's still in a package sitting on my desk, and I haven't taken the time to muck around with it. So this does he have a library that you're using to access that?
He does, and that's the one that, as I say, had the wrong driver in it, even though his comments say that it has the right driver and it doesn't. So that's, I found several things wrong with that chunk of code. That number one, it had the wrong I2C driver. One of the header files, he had one line duplicated 6 times. He hadn't, he cut and pasted it and he didn't change they all said like X low, X low, X low, and it should say X low, X high, Y low, Y high. So I went through and copied it from another one of his header files and fixed that. And there was one other thing that was wrong with it. Now I forgot what it was. But anyway, I fixed a couple of things and finally got it to run. And it's basically demo software. So I got to get to the point where it's close enough that I can see if the thing is stable and if it calibrates correctly and points in the right direction. And then I have to say, okay, hack the output of that to put out whatever code I want. And then I have to take somebody's random ROS driver and say, take the numbers in and publish it as whatever I want. So that I still got much screwing around ahead of me to do that. And either one of these I pick has the BNO055 and this Tindy one from Tindy. Both of those have a motion coprocessor built into them. So theoretically, if the thing's set up correctly, you hook it up and it starts spitting out the values to you, so you don't need extra like Kalman filters or Magic filters or something to make it run. And the interesting thing is the one on the BNO055 that he has, which that code did load and run once I figured out how to load the teensy stuff. It has, he prints out on the thing, he prints out the hardware values. So he's reading them right out of the chip. He puts out the yaw, pitch, and roll. And then he's also got one of the random filters. I don't know if it's the Magic or which one it is, but he's got that in the software. So he does his own software calculation. He's got the hardware calculation. He prints them all out at the same time, which seems great, except the software values aren't right. So I haven't figured out what's wrong with those yet.
What's the guy's last name, Jeff?
Weiner, Winer. And I think his GitHub is like K Weiner. I could probably go look it up here.
I'm just trying to find.
He's got stuff all over the place, and none of it seems to be connected really well. So he's got a Tindy website, and he's got I think he also goes by One Horse is his company name, and like Tierra is another name that he uses. And then he's got this other guy writing software for him that wrote the calibration stuff. So the stuff's spread all over the place, and just trying to find whatever's going on.
I found, I think, a GitHub reference. I don't know if it's the right one.
That is the one for the BNO055. And if you back up, in fact, I think that's probably that is the one that I used. So if you back up to his main, just click on his Chris Weiner thing there, and then it'll say, here's all the different ones he's got. And the one that's called the EM7180 Central Sensor Hub.
I see it.
That's the one that you get on Tindy, and he's got 2 or 3 versions of that. So his older board had that MPU 9250 chip on it, and then he's got it to run on various different processors. In fact, here again he lists that he says BMX 055, which I think that's the one I'm actually running. Maybe I should back up that one you just found. That would be a better source of doing this stuff. So, but anyway, he's got a bunch of different stuff, and if you dig through his somewhere it'll say, here's my Tindy. Right, it says tindy.com products. That's one way to find it. But he's got a lot of blog stuff you can go look at that he tells about how this stuff works, and see how long it would take to find that. And this stuff gets duplicated and you don't know which page you're looking at.
I'm going to get something out of my backpack here. This is a ruggedized Android phone. Not that I have time for it, but the thought process was to try to see if I could use it as basically a sensor platform. One of the I'm trying to get to description of this this thing. Yeah, you won't be able to. You might be able to see it. At a terrible angle there. What this thing is, a 2 gigahertz 8-core processor in it. The device name is Bravo Lima 6000 Pro, BL 6000 Pro. I've seen them as low as $400. It's got a 16. I'm just amazed at this stuff. It has a rear-facing 448 megapixel camera and a front-facing 16 megapixel camera. Like, it's got 8 megabit of RAM and 256 gigabytes of storage. I'm chuckling because I'm like, oh my heavens, that's just like a crazy powerful device. Anyway, it would be interesting someday to think that, you know, something that size could be the a key either processor or at least sensor aggregator, or provide IMU data. It would be a very expensive IMU, obviously, but if that was the only thing that it provided.
Well, people are driving their cars with a cell phone, so I assume it should be able to handle a tractor.
Yeah. So pardon the background noise if you hear my 16-year-old son hooting it up. Bob, anything to share? You've been on mute.
Oh, I tried sending a chat message about Jeff's control bar for the deck. And I was wondering if there was room behind that metal housing, you could put an actuator in there and thereby eliminate the control bar that's in conflict with your motor. What do you think?
Well, part of the problem is the gas tank also goes in that space. So no, there's no room inside to put anything.
Oh, okay.
And I got to keep remembering that, because I look at it, yeah, I got a lot of space there, but I realize, oh yeah, the gas tank has to go back on, and that takes up most of that space.
Details.
Yeah. And that's why I'm taking so long on it, because if I just jump in and do it, I'm thinking, oh crap, now I got to put the gas tank back on, or I got to do this, or I still got to be able to start the thing, or whatever it comes down to. Is there's still lots of things I got to do there. So I posted a link out in the chat, and that's the so it's actually on that same GitHub. It turns out that when I go look at it, but he's got a thing. If you look on the site here, he's got this menu. It says the short survey. Here's his reference design. It comes down to like I found this because it was down to the F where it says magnetometer and accelerometer calibration. So he's got a good write up on how all this stuff works. And you just dig through all that. That's very, very handy to go through all that. Now, the problems I'm having right at the moment, it all says, well, this is test code to make these things work. And sure enough, it is. You fire it up and it says, well, I initialized that. I'm talking to this. I got back these values. And here's the values that it's spitting out. But the one for the BNO055, it starts up and says, okay, leave the thing still on the table. So you fire it up. Like 30 seconds later, it says, okay, I've calibrated the, in fact, maybe if I look at this one. I think that's what it's telling you right here. It starts, you can't read this, but it starts up and it says, I think it says leave the, no, it's something else. But anyway, it looks like it really is test code. It's not meant to be used. So I don't know when it all comes down to it. I don't know if you can just turn the thing on and have it point north and know what's going on, or because both of these seem to be, once you get them running, then you have to kind of wave them around somewhat before the fusion algorithms lock on. So I don't know what to make of that. If you let it sit there, if it will go ahead and start up on its own, or if you'd have to put something on to wiggle it on the tractor. So I don't know. But anyway, he's got a lot of stuff here. And this is some more of the stuff I'm saying. He's got lots of data and nothing really points to anything else. So this is one write-up he has, and he's got write-ups all over, like say on the SparkFun website and the Arduino website, and he's got lots of different write-ups on how IMUs work, and he's got good comparisons between different models and all this kind of stuff. So he seems to know what he's doing, and if the code I was trying to use would have worked a little better right up front, I'd be happier. And if it wasn't just simply test code, that would be good too. And a minor note on that, this one that I got in the Matt also has one of these, and Matt has one hooked up to a Raspberry Pi, and he's running somebody's Python code on the thing. And Walter from Utah bought one of these.
Can you hold that up again?
What?
Can you hold that up again? What was it? Look, in the ESP connected to, or no?
It's a Teensy 3.2 connected to the board from Teensy, what he calls the ultimate sensor fusion something. And that's one of those links that I was pointed to. So this is just a little chip that, and he said the MPU 9250 chip has been discontinued. So he made this board that has that EM 7180 chip on it, and it's got like 3 of the parts from Analog Devices on it. So it's got one chip is an accelerometer, one's a gyroscope, and one's a magnetometer. And he's also got a barometric pressure sensor on the board. So you can get if you want to try to measure altitude using that, it's all hooked up. So Matt took that chip and hooked it up to a Raspberry Pi, and then I found, it went down that chain to see where he got it from, see where that guy got it from, and he's got the thing running on a Raspberry Pi, which isn't where I wanted it. I wanted it on a Teensy or something to start with. So that's why I went down this path this time. And it could be that once it's all calibrated and working, you could go back to either directly connect to the Raspberry Pi or possibly even run Python on a Teensy. I don't know what it takes to do that. So again, I'm just kind of right in the middle of this whole journey, trying to figure out what's available and how it all works and what to do with it.
I mean, the IMU thing has always been a challenge. Are you envisioning calibrating it off vehicle and then installing it on the vehicle, or are you going to try to calibrate it on vehicle?
Well, that's more of the whole journey, isn't it? Because someone says, it says to calibrate it correctly, you have to pick it up, you have to rotate it around like this a long time, and then somewhere else says, oh, in fact, in this guy's write-up, he said something about either him or the other guy that's writing the software for him says, yeah, you rotate it like that unless you have to bolt it down to your vehicle solid, and then you can't do that. But he never tells you what to do about it in that case then. But he says, just rotate it flat on the table does not cut it for you. You have to do it in this other method. So the only thing I can think of at this point is go ahead and calibrate the magnetic thing, off, hold it way out, hold it way out here so it's away from everything, and calibrate it. And then when you're done, move it towards the vehicle. And if it doesn't seem to affect the calibration, if it doesn't screw it up, then go ahead and bolt it down and hope it works. Because otherwise, I don't know I was going to do some research. There's something from one of the military groups. I don't know if it's the Army or Navy or whoever, but they put out a big paper on IMUs and bolting them down and what to do, how to get around that. So I haven't read that yet, but that brings up another whole can of worms on this stuff to try to figure this stuff out. And it's also annoying, when you first turn it on, it says, okay, here's the angle, but it says the thing is not converged yet. So it says, okay, now you got to kind of wave it around until it converges. Well, that's not going to work if you have to bolt it down to the vehicle. And I don't know if you just drive the vehicle around in circles for a while, if it converges, or so that's just more issues that come up that I don't know what to do about.
Bob, I don't know if you meant to, but it appears your hand is raised in Zoom.
Yep. I wanted to ask Jeff a question about, I'm going to focus on using a Raspberry Pi. And I was wondering how Matt hooked up that chip that you talked about. I'm assuming he was using ROS, or how did he wire it to the Raspberry?
Well, that's two different things, but yes, he was using ROS. And to hook it up to Raspberry Pi, there's just the two I2C pins on the Raspberry Pi you hook it up to. And
okay,
I don't know how long it would take me to find that stuff. He posted it out on Slack originally, and it could be that's out on either the Droder GitHub or on the Ross Agriculture GitHub, because I had instructions that he'd written up that I was following. And if it's not one of those two places, then again, talking about all the random stuff, it may be out on the Google Drive posted as a write up there. So I don't know how long it would take me to find that.
okay, I'll look. Thank you.
But again, I'm not suggesting you run out and buy one of these, because it may never,
Oh, no.
It may never work. I do recall that when I was just this time when I was going down the path looking for stuff, I did find, first I went to Matt's thing. So somehow I found Matt's stuff, and I don't remember where it was. It might've been on his Droder GitHub. So I found it, and I pulled it up, and it said this was forked from. So I went and looked at that guy's stuff, and he said he forked it from somebody else, and they're doing everything in Python. And the stuff I'm doing is done in like C on the Teensy. And at the time when Matt was doing it, I thought, yeah, it's great that he found that. And he found it because he searched for, actually it was it was the Teensy one, or the Tindy one they had, not the BNO055. So he simply searched for that, and he searched for ROS driver, and it popped up, and he said, oh, here's one that's written in Python. It's actually got the ROS driver with it. And that's what he loaded on, and that's what he went with. Then he's complaining, well, it doesn't always work right, and he's having magnetic calibration problems. And it turns out, I don't know if he ever did the magnetic calibration. So somebody needs to go down that path and decide if these are calibrated correctly, will they actually work? And that, again, that's where I'm at this point, just trying to figure out if we can get anything out of these and make them useful.
Okay.
Yeah.
And as far as you say, if you're saying you want to go down the path of the Raspberry Pi, well, keep in mind you can do that, but you're going to have, if you have an external processor doing all your low level stuff, number one, it might be easier. Number two, it might be more precise. It might just simply work better to have a Raspberry Pi and a little microcontroller tied together to do this stuff. Now, I realize there's a lot of stuff you can do directly on the Raspberry Pi, but I'm sure you're going to find things that won't work on there. And keep in mind, you're running along with Linux, so it's not going to be real time. It's going to be all kinds of funny things going on. But to start with, you can start playing with that and until you run into problems, and then decide what to do with it after that.
I think I'll start out with it, and like you say, eventually, as I get more sophisticated, then switch at a later date. But right now, I'm just trying to use the boards that I have, so I can justify my past expenditures.
Yeah. I thought at one point you had some Arduinos and some other stuff laying around that, that's an Arduino will work for most of this stuff. So anyway, you'll as you go down the path, you'll think, oh, this isn't working, or this needs to work, or you go find somebody's example using a specific device, and you say, oh, I've got one of those, or I don't have one of those, you can decide what to do about it at that point.
Okay, thanks.
Okay. And that's all I got.
I think I'm in the same spot. Bob, anything else?
I took Jeff's idea or suggestion. I had a problem with my original control box being too small. Part of the problem was I was using too heavy gauge wire. It was primary hookup wire, but I'm going to a bigger box so I can put a Raspberry down in the box and still have my controls up on top. But I'll see if I can get some pictures of it and show it next time.
Oh, it just occurred to me, if people want the chat, make sure you save it.
Yeah.
Or do,
Oh.
do you put that somewhere, Al, or not?
I will try.
Okay. I saved it on my end, so I've got it. I at least have it.
When I say file, I have like 4 different options here, but none of them just say save it to the C drive.
The thing next thing, the ellipsis, the 3 little dots, click on that. It says, you say save chat. It just puts it out in its own directory. I think it's under documents, Zoom, something.
Thank you. I just did that. So Bob, are you good?
Yeah, thank you.
Well, gentlemen, have a wonderful weekend, and we'll see you around on Slack until next week.
Okay.
Sounds good.